In this video, we're going to run Service 4 and look at the performance of the service while it's running and see what is happening. We have the familiar setup of an N1 screen to show system and process level activity, and a command line from where perf will be run to generate some HTTP traffic for Service 4. As the perf clients start to generate traffic, we see that the message rate is starting to increase, but only very slowly. It has gone from 1 TPS to 6 TPS, and leveled out at almost 7 TPS. Not what we were expecting, so what's going on here? Looking at the N1 display, then we see virtually no CPU usage on the system at all. The top two processors showing a little CPU activity are the ones for integration servers PD server and PD client. Some messages are being processed, we can see that from the perf report, so it must just be very slow processing. And to see what is happening inside the message flow execution, then we need to use accounting and statistics data. So let's go into the web UI and take a look. Service 4 is hosted in an integration server PD client. So let's look in that web UI first. Let's navigate to the flow statistics view that shows us a summary of the flows that are running. And here we can see that Service 4 client has a very high average elapsed time of over 3 seconds. And a low average CPU time of less than half a millisecond of CPU. Remember, when we see this type of situation of high elapsed times and low CPU time, there is a delay somewhere. To see what is going on in Service 4 client, then we need to drill into the detail. So let's do that and select Flow Statistics again. As we navigate down to the Flow Schematic view and see the times for the individual nodes in the message flow, then we see that the cause of the delay is in the node HTTP Service 4 request node, which is waiting for about 3 seconds. As the HTTP request node is a very straightforward node that makes an HTTP call and gets a response, then the issue is most likely with the service being invoked rather than in the HTTP request node itself. We can select the HTTP4 service request node in the schematic view of the message flow, and it will show the node's properties. So we scroll down to see the value of the URL specifier to see which service is being invoked at runtime. It might not be the one that is coded statically in the message flow, of course. But let's have a look at the message flow source as well. And we can see that it's the same in this case. Next, we need to see what is happening in the service being invoked. This is Service 4 server. So let's go into the web UI for PD server, which hosts the service. Again, we want the flow statistics view for this service. And when we get to the summary view, then we can see that Service 4 server also has a high elapsed time of around 3 seconds and a low average CPU time of 1.4 milliseconds. This tells us that there is a delay in the message flow somewhere. To see where, we need to get to the message flow node breakdown for this message flow, so we select Service 4 server and click on it. As we get down to the per node times, then we can see the issue is in the node Service 4 server compute. We now need to see the logic that is in that processing node, so let's go to the ACE Toolkit to see the message flow source. In the ESQL, we can see a sleep for 3 seconds, which is the size of the delay that we're looking for. So problem solved. Again, it's contrived so that it's easier to demonstrate a point. In practice, there could have been multiple nodes causing a delay, and we would need to look at each of the nodes that were showing a high elapsed time and investigate the causes. That is it. We found the cause of the delay again. In this case, it was more involved to find the root cause of the delay, as the delay was not in the client service but the service being invoked. But we first noticed the issue when looking at the client flow. This situation is quite common when there are many flows or services being invoked.